Hello students, welcome back to the Advanced Manufacturing Systems lecture class 4. This is the last lecture class in this chapter 3, Advanced Manufacturing System in the Elements of Mechanical Engineering course. This is the 5th module. This is the last topic, last lecture class. Today we are going to discuss about the robot configuration. It is very important from the exam point of view. Advantages, disadvantages and applications of robot. First, we'll discuss about the robot configuration. There are 5 types of robot configuration: Cartesian configuration robot, cylindrical configuration, polar or spherical configuration robot. Fourth one is jointed arm robot configuration. Fifth one is CAR, selective compliance assembly robot arm. The first 4 only we are going to discuss. That is very important from the exam point of view. It will ask for 10 marks. So Cartesian configuration robot. Cartesian means, so in this, movement of the robot is designed to move parallel to x, parallel to y and parallel to z axis of the Cartesian coordinate system. So I will show you what is that parallel to x, parallel to y, parallel to z. I will show you. So it is capable of moving its arm to any point linearly within a rectangular workspace. So it is capable of moving its arm to any point linearly. So linear movement. So in this Cartesian configuration, we have only the linear movement, no spherical, no cylindrical. So it is a linear. So within the workspace. So workspace, that is, what is the meaning of workspace? A space is also called as volume, work envelope. All words are same. Workspace, work volume, work envelope, all are same. A space which is a space in which a robot can move and operate its wrist. A space, okay, is a space in which a robot can move and operates its wrist. So the robot, say for example, is a rectangle. So in this way only robot will live. So this is the, for example, y direction. So this y direction it will move up and down. Next, x direction. This is a linear movement. Next, this is z direction. So up and down motion. So x, y, x, then z. So in these 3 directions, this is a rectangle. It forms a rectangle. Okay, that is why the name is given as also called rectilinear or gantry robot. It is mainly used for pick and place robots for assembly, loading and unloading. A crane, you want to see in the company industries, a big crane, a gantry crane will be there, where you have to lift the load from the down. You have to lift the load and play heavy load, and you have to place it on some other place. Okay. So Cartesian coordinate configuration. Okay, the robot arm can move parallel to x, parallel to y, parallel to z. Okay. So parallel to x, parallel to y, parallel to z axis it can move. So a space in which a robot can move and operate its wrist, that is called as workspace. It is also called work volume or work envelope. Since the arm movement is linear, the robot is also called as rectilinear or a gantry robot. You see this. So now this is a pictorial view, and this is a workspace, and this is 2D view. So it is recommended that you can draw this view and this view, because 3 views are there. So you're able to draw this pictorial view is okay, but so it is recommended, suggested for you that you can draw 2 views for every robot configuration. We have 4 robot configuration. For 4 you can draw the 2 views, this win and this view you can draw. Okay, so pictorial view. See here, this is the wrist, this is the arm, this is the arm, and this is the wrist. This wrist means is a gripper. You can see 2 grippers are there. How we have the holding the gripper, that is called a gripper. These 2 things are a jaws, is also called as a gripper. Able to move in z direction. This is x direction and this is y direction. So it becomes a rectangular workspace. It becomes a rectangular workspace. So up and down motion z. Okay, this type of x, the longitudinal motion x, forward and backward, and again one more linear motion. Okay, forward and backward. So totally we have 6 motions. So you see here x. So this is x direction. So it can move in this x direction, and here also you can see the motion x x, so this x, okay, and this x. Y direction, so this is a y direction, and here also one more y direction, and one more y direction. So this is one more y direction, 3 y directions, and this z direction, so this is one z direction, and one more z direction here, and one more z direction here. So this is a rectangular workspace. Within this workspace, the robot arm able to move. That is why we call it as a rectilinear, okay, rectilinear configuration. So this is a 2D view. Next, we have advantages is simple controls due to linear movement. So all the controls are very simple. So you need not worry much about the control system. Very simple and easy to visualize. There is a high degree of mechanical rigidity, accuracy, and repeatability. What is the meaning of rigidity? So rigidity means when it is lifting the load, it will have the stability. It will not vibrate much. Okay, so rigid, it will be strong to withstand any kind of forces, external forces. Okay, that is rigidity is more. Understand? So it is able to withstand the external forces. It will not vibrate. It will not have any kind of vibrations when the load is there. So it is having high degree of mechanical rigidity. Next, accuracy. In the last class I told about the accuracy. Accuracy means what? Degree of closeness to the true value is called as accuracy. Degree of closeness to the true value is called as accuracy. So repeatability means repeatedly the same value it will give. That means it will have the same. It will not make any kind of mistakes. Okay, first time how it is doing, in the last object also it will do in the same mood. Okay, first object in what way it has taken and it has placed the same way, the same distance, same thing. Okay, without any making any keeping that, placing the object in the distance, it will do the correctly. Okay, for example, object, a robot has to pick up an object and it has to place at a 1 meter distance. Okay, at a 1 meter distance. First object it has took, second object it will make. So even 10,000 objects are there, means 10,000 lost object also it will be placing at exactly at 1 meter distance. Okay, even small incremental changes also will not be there. That is repeatability. Okay, so the same kind of work it will do for the first job and for the last job also, and it will give the same readings also. No changes in the readings, no errors will be there. It can carry heavy loads. That is very important. It can carry heavy loads. That is why we call it gantry. Gantry means to lift heavy loads in the crane, using a crane. Gantry cranes are there. Big machines will be there in the industry. So this it can lift the heavy machines, heavy loads. Since the movement can start and stop simultaneously along 3 axes, motion of the wrist hand is smoother. So wrist motion is very smooth. Its disadvantage: the arm movement is lifted to a rectangular workspace. Arm movement is limited to a rectangular workspace. So it will not have any other. Okay, it knows only linear direction, x, okay, y, z, linear. So it does not have any other rectangular space. Only it is able to move. It does not have any problem. It will not move in a cylindrical fashion or in polar, spherical. No, it is limited to only rectangular. Okay, it needs large space. Second disadvantage, it needs large space. Next, coming to the application, we can use this for assembly, welding, machine loading, unloading, surface finishing, inspection, etc. Next, coming to cylindrical configuration. In this, robot arm is designed to move cylindrical coordinate space. So the previous one, Cartesian, is rectangular coordinate space, but here cylindrical coordinate space. You will see now the figure, will understand. It is a vertical column and slide that can move up and down along with the column. So it has a vertical column will be there and a slide that can move in up and down fashion in the column. The column can rotate, it can in a vertical axis, and hence is capable of achieving workspace in in a cylindrical manner. That is why it is a cylindrical configuration. I will show you the figure. See here. So this is the a pictorial view. As I told you, you can omit this in examination. Only this figure and this figure you can draw. So now this is a work volume, the cylindrical volume. So this is work volume. So from this is x direction and this is z direction. Only two directions are there. So it will move in this only. Okay, this only, and it can rotate. In this same thing, it can rotate. Arm can rotate. So workspace. The column is there. As I told you, column. The column can rotate about a vertical axis and hence is capable of achieving the workspace in a cylindrical manner. So thus this column can rotate. So that it will achieve in a cylindrical manner. Work will be achieved in a cylindrical manner, which we call as a cylindrical configuration. So these two directions only, x direction and z direction. No y direction here. Only x and z directions are there. So this is the 2D view. So x direction forward and backward and z up and down motion, and this column can rotate like this so that you can achieve the cylindrical motion. Coming to the advantages, a large workspace than Cartesian. So previous limited workspace, but here you can large workspace. Okay, so large workspace than the Cartesian configuration. Easy to program. So that is the advantage. Next disadvantage is less mechanical rigidity. So rigidity is less here. That is, it will have some vibration. So if it carries a heavy load, it will have vibrations. Okay. Say for example, your two-wheeler is there. Okay, two-wheeler. So two-wheeler, what will happen when you, for example, Hero Honda or some other any two-wheelers, when you increase the speed, so 100, 120, that your vehicle two-wheeler, it will start vibrating. So the road grip will be very less at the time. So you must be careful. So that is rigidity. The body, that two-wheeler body will not withstand that much of force, as a velocity, because of the vibration starts. Okay, at the time you must be careful. Okay, to reduce the speed. So here this mechanical rigidity is the same thing. Vibrations, more amount of vibrations will be there, and because of that there will be a danger situation prevails. So because robots with the rotary axis must overcome this inertia of the object when rotating. That is the why it will come is they are telling that because of rotary axis is there, because of the inertia it has to overcome, it has to there, because of that less mechanical rigidity is there. Next, repeatability and accuracy is reduced. So their repeatability accuracy is more, here reduced. So requires more sophisticated control system. So more sophisticated control system. That is, okay, you require a highly sophisticated control system than the Cartesian configuration. So applications comes here: pick and place operation, machine loading and unloading, investment casting, forging operation, coating applications you can use for this cylindrical configuration. So next comes polar configuration. Polar means like a spherical, partial spherical sphere. So in this workspace within which a robot arm moves in a partial sphere. So how sphere is, you could have seen sphere, ball, football, volleyball, as a sphere, spherical shape. Okay, it will be moving in that fashion. It has rotary base and pivot that can be used to rise and lower the telescoping arm, similar to the formation of an arc movement. It will have some arc movement. I will show you that figure. The sliding arm can be extended or retracted. See here. So there is a rotary disc is there. You can see the arm is there. Okay, it makes a arc movement. So this is the arc movement. What you can see here is a arc movement. Arm can move, arc movement. So this is having a circular fashion. Base is circular fashion. This arm will come in this direction, linear direction. These are the grippers. This is the arm. This is the gripper. It can pick up in spherical way. Object can be picked up in spherical way. Next, coming to advantages, it can generate large working envelope compared to previous two. Workspace will be more compared to the previous one, previous configuration. That is the two configurations, cylindrical configuration and Cartesian configuration. A simple in design and easy to program. Provides good weightlifting capabilities. Disadvantages, again same, reduced mechanical rigidity, needs more sophisticated control system, limited vertical movement. Vertical movement is less, only horizontal and rotary movement. Next, applications: die casting, injection molding, forging, material transfer applications, etc. So these are manufacturing process. So die casting, injection molding, forging, material transfer, all these are manufacturing process. Next, jointed arm. Last one is jointed arm configuration. So it is similar to human arm. How a human arm is there, the same way consists of two straight components corresponding to the human forearm and upper arm mounted on a vertical pedestal that can be rotated about the base. So the configuration gives three rotational moments. You can see here, like a human arm, it is the upper arm and forearm. So is the forearm is like is upper arm. Mechanical, it's a gripper. The jaws are there. In this gap, it will hold the object. So this is the motions we have. This is elbow, is joints, and this is the shoulder. This is the base. So this motion, rotary motion you have. This kind of arc motion, and again is a arc motion is there. So totally in this 6 degrees of freedom you can see. 6 degrees of freedom is independent motions. Okay, degrees of freedom is the independent motion. How 6 degrees of freedom. So next comes advantages. Most flexible configuration that enables the robot arm to move in all directions. So all directions it can move. Large work envelope, versatile configuration. It can accommodate any kind of objects. Disadvantages: requires complex programming. That is the first difficulty. Disadvantage: control actions are difficult, less stable. Applications: you can use it for painting, welding, automatic assembly, pick and place operations, etc. You can use this configuration. So advantages and disadvantages of robot. This is general, not only for this configuration. It's generalized robot advantages. This is also very important from the exam point of view. First advantage is it performs operations precision and high precision and repeatability every time. It can continuously work. So human beings will not work continuously. Robot can work continuously. Robot increases workplace safety. So workplace safety is there. So human beings need not worry about that. Robots reduces production cost, time and material waste, thereby helping the financial savings. Robots can program to perform variety of tasks. It can perform. As disadvantages: high initial investment, high maintenance costs. Robots are incapable of performing tasks outside their predefined programming. This, as I told you earlier. So here there's you have to define everything. Program. Okay, without programming, self-intelligence is not there for the robot. Everything you should teach that. After that only it will reproduce. Okay, it does not have any self-intelligence. The example I gave in the last class is the snake. Say for example, snake is there. Snake, it comes, simply it will be there. But when we see that snake, we will just run away from the place. So that is the intelligence point. So hence they cannot replace the completely human labor. Okay. Robots cannot move easily as human beings. So human beings, we are flexible. We can move anywhere, anyhow, in all directions. Okay, robots have some predefined paths are there. It has to move. Robots require considerable human intervention. Human intervention. Without human intervention, it will not do the task. Some human intervention is required to perform some complex task. And if you use this, unemployment problems will be there. Okay, instead of person labor, okay, if you just adopt a robot, for even in foreign countries and all, they are using for housemaid. Okay, they are cleaning purpose. Understand, for preparing the food also they are using the robot. So almost all places you could have seen in coronavirus, COVID, China, they have used robots to deliver the food items for the COVID patients for the wards. Okay, robot would have seen. And some hotels in Bangalore also, they have the robots. So almost all places robots we are using because of that employment problems. Okay, I will not get the employment. Because of this, unemployment problems will increase. That is one of the disadvantage of the robotics. So as a whole, robotics will have robots will have a lot of advantages and also the disadvantages. But future trend is on robotics. Next, we'll go for application. So we'll categorize these applications in three ways. First one is material handling application, the material transfer and loading and unloading. Material transfer means you have to shift the material, okay, transport the material from one point to another point. Okay, for that you require the robots. Okay, so pick and place so is also one of the material transfer. You would have seen this in big industries, mega factories. In Discovery Channel, they show mega factories. There, so many robots they accommodate in the companies. Okay, transfer the material from one place to another place. You have to package a container. You have to just transport. At the time, robots will come into picture and it will transfer big packaged item into another place. That is a material transfer. Loading and unloading. You want to load some items into a truck or a wagon or anything, you can use a robot. Unloading also robots can be used for same thing. Processing application like welding. You want welding, you can do welding. It will do. Robot will do. For spray painting, okay, that is also done by the robot. Grinding, so grinding operation. Grinding means making finishing operation. This is called grinding operation. Dip coating, you want to apply any coating, any nickel coating, anything, that is also possible by the this one. Many things are there. I told this in assembly and inspection. Assembly, so car assembly in car, most of the car companies they are using robots for this one, making the assembly of the car parts. And then inspection also, quality control, they have to inspect each and everything. At the time also robots are used. So robotic surgeries are there. So many ways, many places we are using the robots. Robot has become a very vital part nowadays in our human in the life. So this is what the robotics chapter. This is the last class. Thank you for watching this video. You prepare for examination. If any doubt is there, please clarify. Thank you for watching the video. So totally 4 videos are there on this advanced manufacturing system. That is the 5th module. This is the last lecture class on this introduction and this advanced manufacturing system module. 5th module. This module is completed. Thank you.